and we'll continue with what we have been learning last time, that is heat and temperature. And today we'll be discussing more about how heat is transferred, the processes through which heat is transferred. As you know, heat causes change in shape, isn't it? It changes the state of matter, it causes expansion. So heat is transferred from one body to another. So how is it transferred? Okay, to which process will it be transferred? So there are three ways in which heat is transferred, the three ways are called mode of conduction, mode of transfer of heat. So there are three ways in which heat is transferred: conduction, convection, and radiation. Conduction, in which energy is transferred by direct contact. Convection, in which energy is transferred by the mass motion of molecules. That means molecules move up and down. And radiation is transferred by electromagnetic radiation, in which the particles, they do not have to be in contact. Okay, whereas in conduction and convection, the particles have to be in contact. So these are the three modes of transfer of heat: conduction, convection, and radiation. So these are the three ways in which heat are transferred. Okay, the first one, conduction. So conduction is the direct flow of heat through a material resulting from physical contact. So let me give you an example here for conduction. Say a teacher comes in the classroom, you have your unit test, and the teacher comes in the classroom, and what she does is she just goes to the first benches and she just gives the paper to the students who are in the first benches and then says, pass it to the rest. So what do you people generally do is you give one for yourself and for your partner, and then you pass the rest. And the second person who is sitting on the second bench would just keep one for himself or herself and then pass the rest. And this is how the seats, the answer scripts are distributed. Okay, so this is exactly how conduction would take place. Okay, where the particles, they simply vibrate in their place. They do not move from one place to another. And despite that, the heat is transferred from one particle to another. Another one is convection. Convection, heat transfer between a surface and adjacent fluid, and by the flow of fluid from one place to another induced by temperature. Which means, in convection, the particles, they move from one place to another. Okay, so in convection, what happens? The particles which get heated, they start rising up, and then the cold particles come down. So the example for this convection would be, if I ask the students to come one by one and take the answer script. Okay, instead of taking to the respective benches, I ask the student to come one by one to take the answer script. So what do you have to do then? The student have to come and take the answer script from the teacher and then go back to their respective place. So what is happening over here? The particle, they are moving from one place to another. And the third one is radiation. In radiation, no transfer medium required. So you don't need any medium for the transfer of heat in radiation. It's a transfer of thermal energy through matter of space by electromagnetic waves. Okay, so no medium is required. The particles do not have to be in contact. Heat is transferred because of the electromagnetic waves. And we'll be learning it more about it later. As of now, just understand about the difference between conduction, convection, and radiation. In conduction is through direct contact. Convection and conduction takes place in solids, liquids, and gases. But conduction is mostly faster in solids. Convection, on the other hand, takes place only in a fluids, that is liquids and gases. Okay, it is not possible in solids, because in solids particles are not free to move around. They can only simply vibrate in their own place. Whereas for radiation, No particle is required, no medium is required. So we are not mentioning any state of matter over here. Okay. So these are the three differences between conduction, convection and radiation. Now we start with conduction. As we discussed that heat transfers due to direct contact, and I gave you an example where a teacher just goes to the respective first benches and then hands over the answer scripts and asks the student to pass the answer script. So in that way, the student, they don't have to move around. They simply have to sit in their place and pass the answer script. The same way, what happens for conduction is the particles, when it gets heated, the particle when it gets heated, they start vibrating. Okay, when they start vibrating, okay, say this is the particle and the particle is being heated, this particle is being heated, there are other particles which are closer to it. Now when this particle gets heated, this particle starts vibrating. Okay, when it vibrates, it touches the other particle. And now, when it touches the other particle, this particle also gets heated and then starts vibrating. And then again, when it vibrates and touches the other particle starts vibrating faster. So this is how heat is transferred from one particle to another. The first particle, they stay in their own place, simply vibrate to and fro. They don't move from one place to another. Okay, so this is how heat is transferred through conduction. So heat transfer due to direct contact, either between different materials in thermal contact or different parts of the same material. Materials that conduct heat are called good conductors. You know, those substances or objects which conduct or which absorb heat quickly are called conductors. They are usually called good conductors. And metals are very good conductors. Silver is the best conductor. And collision between atoms, molecules and electrons transfer energy. So when the particles, they collide, then when they start vibrating and they collide with the other particle, what happens? They generate energy. They transfer the energy. And which energy are they transferring here? The heat energy. The conduction, it takes, as I told you, it takes place in solids, liquids and gases. Okay. Solids, why? And most of the conduction is fast in solids, as I told you, because the particles in solids are tightly packed. Okay, so they can easily touch the other particle. And when they can easily touch the other particle, they can vibrate faster and transfer the heat to different particle until the entire object or the entire part of the material gets heated. And metals are good conductors of heat, as I told you. Now what are insulators? Insulators are just the opposite of conductors, which means substances which do not absorb the heat quickly or does not absorb the heat at all are called insulators, like rubber, wood. Okay, they are bad conductors. We can say they are bad conductors or insulators because they do not absorb the heat quickly. We'll be learning more about the practical application of conduction of heat or the effects of conduction. The transfer or now, how do conduction take place? The transfer of thermal energy between two substances that are in contact. The energy flow always runs hot to cold until they reach equilibrium. That means, and we've discussed this in the earlier classes, that heat always flows from a hotter body to a colder body until both the bodies attain the same temperature. So this is what it means over here. Okay, the particles which gets heated, they vibrate and touch the cold particles which has less heat, and when they touch the other particle, the cold particle also gets heated, and then it starts vibrating and touch the other particle, and this is how the heat is transferred. Now, some of the practical application of transfer conduction. So I'm referring from the book. Uses of conductors and insulators. The cooking vessels are made of metal so that they can readily absorb heat and transfer it to the food being cooked. Now most of the metals, or most of the cooking utensils, they are made up of metals, isn't it? Most of the cooking utensils, in fact all the cooking utensils, they are made up of metals. Why? Because metals, as we discussed, are good absorbers of heat. They are good conductors of heat. They absorb the heat. So they absorb the heat quickly. So when they absorb the heat quickly, the food which is cooked over here gets cooked faster. Okay, thus consuming time and saving the fuel. Now some of the other applications over here. The handles of cooking utensils and kettles are made of insulators. Now you know the handle over here, most of the handles that we see either are made of plastic or wood, isn't it? Why is it made up of plastic or wood? So that it's easier to hold it. As wood, plastic, they are insulators. They are bad conductors of heat. So when heat is transferred in the entire vessel and through this, okay, what happens here? The wood will not be absorbing the heat quickly. So it will take time for the wood to absorb the heat. Okay, so till then it will be cold. So it becomes easier for you to hold it. Another one is the quilts, blankets and woolen clothes keep us warm in winter because they trap air in between our body and themselves. Now, it's not there. The woolen cloths, actually the wool, when you just take out a strand of wool, what will you see? It's crinky, okay? It's not straight. So, they are like curls in this shape, like a string. So, they trap the air between them. The woolen cloths that we use, the blankets that we use, they trap air between our body and the wool. When the air is trapped between them, what happens is, air is a bad conductor of heat. Okay, it's an insulator. So the air which is trapped between the body and the blanket or the wool, it's trapped between here, will not allow the heat from the body to escape out. Okay, and it will also not allow the cold from the outside to enter the body. So thus, since air is a bad conductor, it preserves the heat of the body, maintaining the body's temperature. And thus we feel warmer when we wear blankets, when we put on woolen cloths, or on a cold day we prefer blankets. Okay, that's why, because the coolest blankets, they trap air between them. The ice boxes are made up of double-walled containers. Okay, might be here, somewhere here. Okay, I hit over here, but anyways, I had downloaded it. It might not have been here. So next time, in the next class, I'll show you. You know those ice boxes, the smaller ice boxes, the one that is handy, we can carry it and we put ice in it. Okay, those ice boxes are double walled. That means they have double walls. And what is between the double wall? Air. The double wall, that means between the two walls, what is between them? Air. Okay, between the two walls, what is filled between the two walls? Air. And as we discussed, air is a bad conductor. That means it does not absorb the heat quickly. So the heat from outside will not be able to enter through the walls. Okay, it will not be able to pass through the wall. Even if it enters through one wall, it will not be able to pass through another wall. Thus, the ice will remain intact and it will not melt. Okay, so this is how a double-walled ice container works. Now the false ceilings. You must have seen nowadays, isn't it? There are so many the way the houses are made, they add, these are normal ceilings that we have over here, and on top of that they add another ceilings, design it, so somewhat like this. Okay, so the false ceiling, generally made of plaster of Paris or asbestos, provide a layer of air between the two ceilings, which keeps the room warm during the winter and cool during summer. So what happens is, so these are the false ceiling, okay, we already have a ceiling over here, and on top of that you add another ceiling, you design it. So between the two ceilings, air is always trapped between the two ceilings. So when the air is trapped between the two ceilings, what happens is, during the winter, if the room is warm, it will not be allowed to escape out, okay, because of the air which is between the two ceilings. So the air, being an insulator, will not absorb the heat. Similarly, on summer, when you turn on the fan, or say your AC is on, so the room would be cold, so the hot air from outside will not be able to enter inside the room because there is air. So the air will not allow the hot air or the heat to enter through the room, thus maintaining the temperature of the room. Okay, the natives of Alaska made igloos. You've seen those igloos. The same process here. You've seen igloos, isn't it? People who stay in very cold places, they make houses out of snow, and they are called igloos. Why do they make houses out of snow? Because in between those walls and the snow, air is trapped. Thus, when the air is trapped between them, the cold air will not be able to enter inside the house, and the warmth, that is the heat of the house, will not be allowed to go outside, as air, being a bad conductor, will not absorb the heat. So it remains quite warm inside the igloo. The coils of refrigerators, you've seen those at the behind the refrigerators. You might have seen those coils, metal coils, isn't it? And if you ever wondered why are these coils kept over there, it is because refrigerators are used for preserving food, and its temperature has to be maintained. It has to be cold enough, isn't it, to not to spoil the food. So the metals which are kept, the coils of metals which are behind the refrigerators or the ACs, what do? Is they absorb the heat. If there's any heat which flows through the refrigerator or the air conditioners, they absorb that heat. Okay, because metals are good conductors of heat, so they absorb the heat, maintaining the temperature of the fridge. Okay, which means the fridge will remain cooler. It will not lose its temperature, so you can just freeze the food or just keep it fresh inside the refrigerators. Now another one is, what do we use as a thermometric substance in a thermometer generally? It is mercury. And mercury is being a good conductor of heat. It absorbs the heat and increases its temperature, and loses heat and decreases the temperature. So it gives a correct reading. Okay, it's very sensitive. They are good conductors of heat. That's why we use mercury as the thermometric substance. And the last one, you see those animals, they have, those who stay in a very cold places, they have fur, isn't it? They have a lot of hair on their body. It is because the air is trapped between the fur. And when the air is trapped between the fur, they will not let the heat of the body from the animals go out. And neither will they let the cold from outside to enter the body. Okay, because air is an insulator, it just stands over there as a blockage, okay, which blocks the hot heat to go escape out. So these are the uses of conductors and insulators. And we are stopping here for today, and the next class will be doing convection and radiation. Thank you and have a good day.